a statement is not true, and we have given for series, and statements are in option A, B, C, D, R. As first option is saying series is divergent, option B is saying series is convergent, option C is saying option series is convergent, and option D is saying series is convergent, and we have to seek not true statement. So we will check each statement one by one. For first statement in option A, series 1 plus 1 upon root n raised to the power minus n cube by 2. To check its convergence, uh, I let un is 1 plus 1 upon root n, and obvious this one is greater than 1 upon root n because of these two are same and one is added in left hand side, so this will make greater. So it's a reciprocal. If 2 is greater than 1, then 1 upon 2 is less than 1. Means reciprocal can change the sign of inequality. So 1 plus 1 upon root n, and I am doing this reciprocal because of I need a negative power. So 1 upon 1 plus 1 upon root n is less than 1 upon root n. Also, I need n cube by 2 as in exponent. So n cube by 2 I took. So whenever inequality is true, so making power doesn't affect because of n cube upon 2 is a positive. So recall one theorem. If un summation un and summation vn are two sequences, and we have terms of the sequences means un is less than equal to vn, then convergence of vn implies the convergence of un. So I am going to test 1 upon root n raised to the power n cube by 2 is convergent or divergent. If anyhow this is convergent, then I can say given series is convergent. To make or check convergence of this series, I'm going to make this as a p series test. So 1 upon, I know that n cube by 2 is greater than, or I can take 4 because of 1 upon root n raised to the power n cube by 2 can be written as 1 upon n raised to the power n cube by 4. Because of n cube by 4 is greater than 2 for sufficient large value of n. It means that n raised to the power n cube by 4 means make this as an exponent will also greater than n square, and its reciprocal will be 1 upon n raised to the power n cube by 4 is less than 1 upon n square. Means you can make this is a series, and we have this is p series, and value of p is greater than 1, so it will be convergent. If this is convergent, then this one is convergent. If this one is convergent, then I can say this one is convergent, as you can see circular part of. So in option 1, series is convergent, but given series is divergent. So option A is not true. Option A is not true. Now seek option B. In option B, I can say 1 upon n square summation 1 upon n square is convergent by P series test. So B is true statement. Now check option C. In option C, it is given that summation 3 raised to the power minus n minus of minus 1 raised to the power n. Whenever n is involved in the power, always try to solve problem with the help of root test. Root test says if this is un, then un raised to the power 1 upon n. If limit of this expression is less than 1, then series is convergent. So I'm going to applying root test here. So 3 raised to the power minus 1 minus of minus 1 raised to the power n raised to the power 1 upon n, and limit n tends to infinity. Now this is limit n tends to infinity 3 raised to the power minus 1 minus of minus 1 raised to the power n upon n. Now this sequence is tending to 0. So we have limit 3 raised to the power minus 1. It means 1 upon 3, which is always less than 1. So less than 1. So this series is convergent, or you can say you can check convergence, easily find the limit of this expression by complementary sequences. And you can resolve this as when n is even, then we have 3 raised to the power minus 1 minus of 1 upon n, and limit of this expression when n tends to 0 will be 0. So 3 raised to the power minus 1. Again, when n is odd, so you will have minus of plus minus 1, 3 raised to the power minus 1 plus 1 upon n, and limit of this expression is again 0. So final result will be limit of this expression will be 3 raised to the power minus 1. So anyhow you can say in option C statement is true. Now check statement D, which is saying n raised to the power n square upon n plus 1. In the statement n square upon n plus 1 n plus 1 n square, and this is approximate equal to n square upon n n square. Because of this is n square, and I can write n plus 1 as approximate this one. So we have n square upon n cube. So convergence of this one is same as convergence of this one. So if anyhow we can predict the convergence of this expression, then I can easily say about this one. As we know that n square is greater than 3, so taking base as n, so inequality again hold. It means that I have n raised to the power n square is greater than n cube. That means that if you divide by n cube, or this one is increasing, this one is increasing rapidly than n cube. So limit of this expression n n raised to the power n square upon n cube is always greater than 1. So limit of this expression cannot be 0. If series is convergent, then it is obvious that the limit of the nth term or un term will be 0, but I'm not getting limit as 0. So in option D, statement is false, and false means not true. And we are checking not true statement, so option A and D is correct.